Hello, we are back. Another fun-filled, action-packed, non-flipped Algebra 2, not 1 but 2 classroom video right here. Notes number 2, we are continuing with graphing rational functions, but today we're going to introduce 2 new concepts right here. One of the concepts is going to be the holes we talked about yesterday. Remember, one of the 5 attributes yesterday, the only one that you may not know about is the holes. So sometimes the graphs of rational functions have holes or gaps in the graph. And how can you tell when it's going to have a hole in the graph? That is when a factor is in the numerator and denominator, the graph is going to have a hole right there. So if you look at this example, x squared minus 4 over x squared minus 3x plus 2, if you factor out each of these polynomials, it factors out to x plus 2 times x minus 2 over x minus 2 times x minus 1. Now, do you notice a common factor in the top numerator and the bottom? What? What's the whole factor? X minus 2, right. And because this is a fraction, we can cancel those out because we see it on the top and the bottom, right? But because we can cancel the x minus 2 out, that means there's going to be a hole at x equals 2. Why is it x equals 2? Because you got to set it equal to 0. X minus 2 is the factor, right? We set that equal to 0. We solve for x by adding 2, and we get x equals 2. There's going to be a hole at x equals 2. So that is the concept about the gaps or the holes. So next is going to be, some of you guys were asking yesterday, how do I know if the graph is actually going to alternate around the asymptote, right? Like, how do I know if it's going to be on the same side or alternate, whatever? This is the explanation for that. So vertical asymptotes come from solving the factors in the denominator. That's how you find vertical asymptotes. You see how there's factors in the denominator right here? X minus 1 and x plus 2. If you solve those factors, that means set it equal to 0 and solve for x. That's where the asymptotes are. So if the degree of the factor used to find the asymptote is even, then the graph is going to approach the same direction around that vertical asymptote. If the degree is odd, the graph is going to approach opposite directions around the asymptote. So all of that's very confusing when you hear it, but let me show you right here. So you see one of the factors is x minus 1, right? You see that? X minus 1. Yeah. That means there's going to be a vertical asymptote at x equals 1. Okay? There's a vertical asymptote at x equals 1. Now what's the degree on the x minus 1 right here? What is the degree? Squared, right? 2. The degree is 2. Is that even or odd? Even. Because that is even, that means around my vertical asymptote at x equals 1, the graph is going to approach the same direction. So if my asymptote looked like this, right? That's x equals 1, right? And one of my curves looks like this. It's going up. You see how it's approaching upwards to infinity? Then on the other side of the asymptote, it should also be approaching up. It's approaching the same direction around the asymptote. Both of those curves are approaching upwards. Or both will be approaching downwards. And that is because the degree is even right here. Okay? And similarly, if you look at the other factor, we also have x plus 2 right here. That tells us there's also going to be a vertical asymptote at where? Where do you think? X equals negative 2. That's right. If you solve for this factor, x equals negative 2. That's where the second vertical asymptote is. But what's the degree on this x plus 2? 1, right. If you don't see anything, it's a 1. Is 1 even or odd? Odd, right? So the degree on this factor is odd. That means the graph is going to approach opposite directions around that vertical asymptote. So my vertical asymptote, it'd be like this, right? And it's going to approach opposite directions. So if one side of my curve is like this, going upwards, where should my other one be going? Down. It's going to be pointing down like this. You see, opposite. And that's because the degree is odd. That's how you can tell which way it's going to alternate, or if it's alternating at all. And we're just going to do a bunch of examples so you guys can get a hang of this. So let's start with example 1. All right. Looking at example 1, looking at the equation right here, is there going to be a hole in this graph? Yes. Why? Right, because x minus 4, you can cancel it out. That means there's going to be a hole at x equals 4 right here. You can see that they gave you the coordinates, 4, 4. All All right, now the next thing I want you to look at is the remaining factor, the denominator. What is the degree here? On x minus 2. What's the degree? 1. So that's even or odd? Odd. Now remember, odd means opposite. Odd, opposite. Okay? So now look at the asymptotes. We've got vertical is x equals 2. Draw the vertical asymptote. And the horizontal asymptote is y equals 1. And now what are the 2 points that they gave us? Negative 4, 0. So that's right here. And 0, negative 2, which is right here. Okay, so now there's one more thing that we want to graph before we actually draw our branches in. And that is the hole. So the hole, where's the hole? The coordinates is 4, comma. Look at right here. It's right here. 4, comma 4. Right. They're showing you some math here, which is how they got the number. But it's 4, comma 4. So on 4, 4, you're going to draw an open circle. That's how you show the hole. Because that is a point where there's nothing there. If you plug 4 into the calculator, into this equation, it's going to say error. Because there's actually nothing there. It doesn't work. That's why there's a hole at 4, 4. All right, so we can already see with these 2 points right here, the root and the y-intercept, that the branch is going to go through these 2, right? Like we did yesterday. So you can go ahead and draw a branch through these 2. What? Come on now. All right. And then now take a look at where the branch is going, though. On the left side of the asymptote, the branch is going down, right? It's heading in the down direction. So on the right side of the asymptote, which way should your branch be going? Up. And how did you know that? Right, because the degree is odd, which means opposites. So that assures that you should be up. But now here's the thing. You have to make sure that your branch goes through the gap. Like this. Make sure you don't actually touch the horizontal asymptote, but that's what it looks like. Because every point on that curve is an actual point except for that one gap. That's just one missing spot at 4, 4. Right. Where do you see that? Right here? No, you're looking at the degree on the factor. The degree is the exponent. Yeah. This is, look, there's a 1 right here because there's nothing. And so that's odd. 1 is odd. So it goes to 2 there. Yeah. Because sometimes you'll see like this. You'll see like x minus 2 and then with a 2 on the outside. Yeah. If there's nothing, it's just odd because it's like a 1. That's odd. That's odd. Yeah. So now we just need to write the domain. So what is the domain on this graph? X is not equal to, but also x is not equal? No. 4, that's right. Because there's a gap right there. At 4, 4, that's not an existing point. So Omar's right. 4 is the second value that x is not going to equal.
So there's going to be 2 left domains on all these?
It's not 2 domains. It's just 2 things that the domain does not include.
Okay.
Yeah. So it can't be 2 because that's your vertical asymptote, and it can't be 4 because that's where your hole is.
Okay.
Yeah. All right, so let's go to the second example then. Look at the second example. Is there going to be a hole in this graph?
Yes.
Where?
X minus 4, negative 4.
X equals negative 4, right? Because when you solve x plus 4, you get x equals negative 4. That's right. So, and you can see down here they even show it to you, negative 4. All right, and take a look at the factor right here. What is the degree on the factor?
Odd.
1, which is odd, yes. All right, so now let's draw the asymptotes. X equals 1, vertical asymptote. And y equals 1 is the horizontal asymptote. Now, what are the 2 points they gave us?
2, 0, and 0, 2.
That's right, 2, 0, and 0, 2. And what's the one more thing that I need to graph before I draw my branches? The hole, right. Where's the hole?
Negative 4, 6 over 5.
-4, 6 over 5, right. So that's going to be negative 4, 1, 2, 3, 4. And 6 over 5 is barely over 1, so like right there. Something like that. So now, we want to draw our branches, and we can see that right here, using the y-intercept and the hole, our branch will go through both of these, and you can see how it's going to curve.
How do you know where the hole is?
because that's this point right here, like -4, comma, 6 over 5. No, you just put like kind of, like that's not exactly where it should be, right? That's just somewhere over 1 a little bit. So then you're going to draw the branch like this. There we go. Okay, and now on the left side of the, ow, I just bit my lip. Okay, on the left side of the asymptote, the branch is going up. So on the right side of the asymptote, it should be going down. How did you know that? Because the degree is odd. They were very good. And make sure that your branch goes through this point, though, right here, the 2, 0. So it's going to be going down through that point and off to the side. There you go. So what is the domain on this graph then? Not quite. It's x. Remember the x values. X does not equal? -4. The x value on this hole is -4. And also x does not equal? That's right. Does not equal 1, which is the vertical asymptote. All right, so let's go to example number 3 then. Notice on this one, are there going to be any holes on this graph? No, you don't see anything that can cancel out. But take a look at the denominator. Look at the factor here. What is the degree? 2, which is? Even. So this one's going to look a little different then. The vertical asymptote is x equals 2. And the horizontal asymptote is y equals 0. All right, what are the 2 points they gave us?
4, 0, 0, 0,
And 0, -1. Wow, what's weird about this graph already?
It's on the
Right, the point 40 is on the horizontal asymptote. So, that's why we said yesterday in the notes that sometimes you can actually touch the horizontal asymptote. So, now we're going to take a look at where each is going. So on the left side, you see the point that's in this little sector right here, right? That tells you where this branch is going to be on the left side of the asymptote. It's going to go like this, right? So the branch, you can go ahead and draw this one. Okay, so on the left side of the asymptote, your graph is going downward. So on the right side of the asymptote, which way should your graph be going? Down. Why should it be going down? Yes, because it's an even degree. That means it's approaching the same direction. Yeah, so it's going to look like this, going down, right? But then go out the other way through that point on the horizontal asymptote. So what is the domain of this graph?
X is not equal to.
That's right, x is not equal to 2.
Because there's no hole.
Right, exactly, because there's no hole. So it's just the vertical asymptote. Very good. So let's turn to the back side once you graph this one. Oh, okay. Yeah, what? All right, so on the back side right here, are there going to be holes on this graph right here? No, there's nothing to cancel out. But notice, how many factors do I have in the bottom? 2, which means how many asymptotes will I have? 2, that's right. So let's check the degree on each of these. You have to check each one separately, right? So what is the degree on x plus 3? Odd. And what about the x minus 5? Odd, right. And can you tell where the asymptotes would be?
3,
Right.
+5.
Positive 5, right. Because if you solve each of these factors, right, that tells you where the asymptotes are. So let's graph the asymptotes then. Oh, I think my graph moved. And the horizontal asymptote is y equals 0. And what is the 1 point they give us here? 0, 0. And what's strange about this point? It's on the horizontal asymptote. So once again, this is going to cross the horizontal asymptote. Now, if you remember from yesterday, notice how we have 3 regions, right? The middle region, you have to actually check what shape it is. Because I don't know what shape it's going to be. I only have 1 point. So what do we have to do to find out what the shape is actually going to be?
Don't you have to put like one of them to the left?
right? And then,
Put it in for x.
and what else do I have to do after that? You find 1 point to the left, and that's it? Just 1 point to the left, and you're good? And 1 to the right, right. So you have to find 1 point to the left of this and 1 point to the right so you can see what kind of shape it actually makes. And the further out the point, the better idea of what shape it's going to be. So let's choose a value of x that's to the left of that point. What value of x is to the left? -2, right. So let's choose -2 and plug in -2 for x. So we're going to have -2 over -2 plus 3 times -2 minus 5. We just chose a value that's to the left of this point. Where's the point? I can choose -1 or -2.
That's like that.
That's inside the region, right? Because we're trying to see what shape is inside the region.
So it can't.
So it can be -1.
It can't be the -3 because that's the asymptote. Nothing's there.
Can it be -1 too?
It could be -1, but the further out you go, the better idea of the actual shape you're gonna have, right? So -2, if I plug this in, this is going to equal -2 over -7, which reduces to just 2 over 7. So at -2, on the -2, right, it's going to be 2 over 7, which is like just above 0. So there, look, we have 1 point to the left, right? But still, that's not enough to show me the whole shape. So can you pick a value that's to the right? 4, right? Because you want to go... You know, if you can, go as far out as possible. So 4, let's plug in 4 for x. 4 over 4 plus 3 times 4 minus 5 would give me 4 over -7. So -4 over 7. So when x is 4, it's -4 over 7. So it's down here. And now you have a good idea of what shape it is going to be. Because remember, it's either going to be a U shape or kind of like a cubic shape. So is that a U shape? Do those 3 points look like a U? No. So in that case, it's going to look like this. Because it's either going to be a U shape or it's going to be like that. Now that's all really the hard work, because after that, now you're just going to use your degrees to show you where the rest of the curves are, right? So if we look at the asymptote right here, this is the x equals -3 asymptote. It's approaching up, is going up on the right side of this asymptote. So on the left side of the asymptote, which way should it be going?
Down.
Down. Why should it be going down? Because this degree of the x plus 3 is odd, that's right. So that means your curve, your branch should be down here, going down, and then curve off. Because you cannot pass the horizontal asymptotes. Right there, okay? And then if you look at the other asymptote at x equals 5, right, is going down on the left side. So on the right side, bless you. It's going down on the left side, so on the right side it should be going up. So it's going to be up here, and then curve off right there. And that's what the graph looks like. There are the 3 regions right there. All right, what's the domain going to be?
X does equal 3, is equal 5.
That's correct. It's the vertical asymptotes. X does not equal -3 and x does not equal 5. All right.
So for the opposites, how do you know which one to put down and which one to put going up? Like,
Well, this one we found, right? This one we found.
yeah, but like, why is the bottom left one not going up and?
Because right here on this side is going up.
Oh, okay.
So this side needs to go down. But right here it's going down. So on the opposite side needs to go up.
Oh, okay.
Yeah. It's like you look across the line, right?
Well, 'cause this couldn't happen.
Kind of, yeah. Well, I mean, you're just looking around this asymptote, you see? So it's around the asymptotes. All right, let's go to the next example, number 5. Is there going to be a hole on number 5?
Yes.
Yes, where?
-2.
A -2, right. X equals -2, very good. All right, and what is the degree on this factor right here? 1, and that degree means it is odd. And you gave me the asymptote, x equals -5, that's right. And so, right here, boom. There's the vertical asymptote at x equals -5. And the horizontal asymptote at y equals 0. Okay. So, what is the point they gave us here? That's right, 0, 2 over 5. That's like about here. And what else do I need to graph? The whole. Where's the whole?
-2 and 2.
-2 and 2 over 3, which is going to be about right here. Notice right here the whole is higher than the y-intercept, right? So that gives you a good idea of what the branch is going to look like. Because the branch needs to go through both of these. It goes through the hole and the points. So like this. It's going to curve from the top going down. Like this. All right, now if we look around the asymptote, right, over here on the right side, it's going in the upward direction. So on the left side of the asymptote, which direction should it be going? Down. How did you know that? Because the degree is odd, which means opposite. Very good. So down. And boom, like this. Now, can you tell me the domain on this one? And? See ya. That's right, like this. Wait, what? Yeah, when you can cancel something out. Yeah, that's right. Okay, next example, number 6. We're almost done here. Number 6. Is there a hole in number 6?
Yes.
Yeah.
No, there's nothing. What?
No,
There's nothing to cross out.
Oh, shoot.
Everyone is getting excited. What the heck? All right. Well, but let's take a look at the degree, though. What's the degree here? 2, which is even. That's the important part here. Okay, so let's graph the asymptote. It's going to be at x equals -1. And the horizontal asymptote is at y equals 0. And what are the 2 points they give us? 6, 0? And 0, -6. Very good. All right, so what do you see about this? What do you see that's strange about this? Yeah, it's on the horizontal asymptote. But it doesn't matter because you can see the second point here, right, at 0, -6. So you can see that the branch is going to go through both those points. Okay, so you can infer that the branch is going to look like this. Hey, I missed it. Okay, well. There we go. Okay, so now on the right side of the asymptote is going in the downward direction. So on the left side of the asymptote, it should be going down. Why should it also be going down? Even degree. Very good. But on the left side, make sure you don't touch the horizontal asymptote. Like this. If I were supposed to go through this horizontal asymptote, they would have told me that's a root. Because they gave it to you as a root. Yeah. Because notice, right, this horizontal asymptote is the x-axis. So they would have told it to me in the roots. All right, and what is the domain on this graph? What's the domain on this graph? That's right. All right, on to the last one then. Here we go. Are there any holes on the example number 7? No, there's nothing you can cancel out. No holes. But how many asymptotes, how many vertical asymptotes is this one going to have? 2, right, because I see 2 different factors right here. They're both odd. Very good. All right, so let's graph the vertical asymptotes. X equals 2. And x equals 3. And the horizontal asymptote is y equals 0. What is the point that they give us?
0, 0.
0, 0. That's the only point because that happens to be the root and the y-intercept. All right, let's go straight to the domain. What's the domain on this one going to be? Right? Right. Okay, now notice this one also has three regions, right? We got the region on the left side, a very narrow region in the middle, and the region on the right side. So with the middle region, we're supposed to find out what the shape is, right? But to do that, we would have to do fractions, right? Because, there's no solid points in between there. And that's really hard to do without a calculator, so we're not going to do this one, actually. We're just going to leave it at that. So this one, I'm just going to put too complicated without a calculator and leave it at that. We would not give you this to do on the, because this is the fractions. But yeah, that's pretty much the gist of it all, with the wholes and the asymptotes. So that's going to conclude this second day of notes, guys. So until next time, we will see you in the next ones. Peace!